So in this video, we're going to solve a literal equation that involves a product of variables. But before we do that, let's just make sure we understand what a literal equation is. It's really not anything fancy. In the dictionary, the word literal has more than one meaning. And one of the meanings of literal is that it is something that is comprised of letters. This is one of many meanings of the word literal. So in mathematics, it is not uncommon to use the word literal to represent a variable. So all a literal equation is an equation that has many variables in it, many letters representing unknown quantities. And the issue is in the sciences, these are examples from physics, and the issue is in the sciences, there's going to be a lot of different equations that you need to use to solve problems, and those equations in textbooks are going to be given to you in some standard form. So that form will have one of the variables solved for you, but sometimes the variable that you need is one of the other variables. So for example, you might need the variable a, and he's not been isolated, and the textbook isn't going to solve for every possible variable in that equation. What they're going to do is give you an equation like this one, and if you need to solve it for m, you need to solve it for m on your own. So literal equations, they're equations constructed from variables, and your job typically is to take a literal equation and then solve it for one of the other variables. So this one you should recognize. This is the area formula for a triangle, and it says solve for height. It's typical for the area formula for the triangle to be given to you solved for a, the area. If you need something else, you usually need to find it on your own. So if we're going to solve this for h, I'm going to take two approaches to this. I'm going to take a convoluted approach and then a direct approach. So one thing that we could do if we wanted to solve for h is we could see that we're multiplying by a half, and we could decide to multiply both sides by 2, because 1/2 times 2 equals 1, and we would be left with just a 1. The 2's would cancel. So we would be left with twice a equals b over h. And then to get this h by itself, we could divide by b on both sides, because b divided by b equals 1, and then we would get 1 times h is just h, and we get twice a over b. We have an equation that's solved for h. The other way that we could have approached this, we could have said area equals 1/2 b times h, and we could have gotten the h directly by recognizing that 1/2 b is really just b over 2, and we know that if we multiply something by its reciprocal, so if we multiply b over 2, for example, by 2 over b, when we take the product of reciprocals, it equals 1 always, because the 2's give us a 1, and b divided by b gives us a 1, and we get 1 times 1 is just 1. So we could have just multiplied by 2 over b on the right-hand side, which would mean that we needed to multiply by 2 over b on the left-hand side. And the b divided by b would give us 1. The 2 divided by 2 would give us 1, and we would get 1 times h times 1 is just h. And we would have a 2 times a all over the b. So we could have gotten it in one step instead of two. I think when I look at student work, it's more common for them to take this intermediate step.